welcome to this organic chemistry lesson. We'll be looking at alkenes and how we name the alkenes, and so I'm quite excited to get this started. As you might remember, in the previous lesson we looked at how alkenes are the simplest structures of organic molecules, and that is because organic molecules always involve carbon covalent bonds, and alkenes have only single bonds between multiple carbon chains. So if I have a carbon chain here, I will have single bonds in between these chains. Okay, all the other covalent bonds here will then be hydrogens. So they will all be hydrogens. Okay, great stuff. Okay, now you might also remember we called these hydrocarbons, because hydrocarbons only consist of hydrogens and carbons, and that is why this is a hydrocarbon. And then we also said that the alkanes are saturated. Saturated, that sounds like they are full. Okay, I'm saturated, I'm full. That's exactly what it's all about. It's saturated because every carbon has the maximum number of hydrogens that it could have. Okay, obviously this one here only has 2, while this one has 3. That is because he's on the inside, he's connected to other carbons, but all of his other bonds are connected to hydrogens. The point being is it would be unsaturated if he had double or triple carbon bonds. In other words, if he didn't have at least 2 hydrogen bonds. Okay, so this is a saturated hydrocarbon, and let's jump directly into naming these. Okay, naming. The first thing is that alkanes will always have the suffix. Always have a suffix "ane". Okay, it will end on the suffix "ane", and the prefix. So what comes before this? The prefix will be. Is prefix 1F? I think so. Suffix, maybe not. Okay, the prefix depends on the number of carbons in the longest chain. Now I say longest chain, we wouldn't count all of the carbons in the compound, because sometimes we have branches. Okay, so we'll find the longest chain of carbons. That means I go from one to the next carbon to the next carbon, and whenever there's a split, I choose the route that has the most carbons in it. We'll do some examples and then it would make sense. Now, the prefix that comes in front of the "ane" depends on the number of carbons that we have. For example, if there's only 1 carbon, we use the prefix "meth", 2F, and this is not just this is not just true for the alkenes. This is true for all the organic compounds that we're going to learn how to name. All of them are going to depend on the length of the longest carbon chain. Meth, eth. The next one is prop, for, but. Okay, actually bute. 5 would be pentane. 6 will be hexane. Hex. 7 would be heptane. 8 would be octane. 9 would be nonane, NON, and we'll only go up to 8 usually, but I'll give you the next 2 anyway. 10 would be deca or decane. Okay, so this is how simple it is. If I had a single carbon with hydrogens, so I've got my carbon. Okay, there's no other carbons, which means I've got these 8 bonded all to hydrogen. This would be 1 carbon, so he would be called meth, and then the suffix "ane". Okay, if I go to 5, let's say we've got 5 carbons There's my 5 carbons. All of them are singly bonded to each other. Okay, the rest are all hydrogens. And for simplicity's sake, I'm just going to leave the hydrogens out to save some time. But we all know there's hydrogens all over there. Okay, this would be pentane. Okay, and that it's really as simple as that. It's not very complicated. Obviously, it gets more complicated as soon as we add some branches, but we'll look at that in the next video. Now, just for now just for the molecular formula. And I want to look at the general molecular formula. Okay, so general molecular formula. That's referring to if I had any number of carbons, how many of the other atoms would I have? Okay, so let's represent the number of carbons with carbons, and N represents any number of carbons. Now you'll notice that no matter how many carbons I have, each carbon has 2 hydrogens. Okay, all the carbons have 2 hydrogens. So for if I have N carbons, I will have 2N hydrogens, with 2 exceptions. The 2 at the end are not bonded to 2 more carbons, they are bonded to a hydrogen each. So the end points of the carbons would have another 1, 2. Okay, so we will have another, since there's only 2 ends, we'll have 2 additional hydrogens. Okay, and that is really it. That's all I want to say about naming alkanes. In the next video, I will look at what happens as soon as we have a substituent group. In other words, instead of a hydrogen coming in here, we have carbons being added onto here. So what happens now, and how does that change the naming as well as the molecular formula? I'll see you in that video. Enjoy.